10.3 is the quotient of powers property. And our key idea here is to divide powers with the same base. Remember, they have to have the same base. You're going to subtract their exponents. So here we have 4 to the 5th divided by 4 to the 2nd. My bases are the same, so I subtract, and I have 4 to the 3rd. Okay, so let's look at some more examples. 2 to the 6th divided by 2 to the 4th. My bases are the same as 2. Okay, my exponents are 6 minus 4, which is also 2. Okay, so 2 squared is equal to 4. Now, you may leave your answer like this if your teacher wants you to, or you can evaluate it as 4, either way. Part B, negative 7 to the 9th over negative 7 to the 3rd. So my base is negative 7. Notice that I brought the parentheses with it. That does matter. And then 9 minus 3 is 6. So negative 7 to the 6th power is your answer. And if I evaluate that, it's 117,649. Once again, check with your teacher on which type of answer they want you to leave. Part C is h to the 7th over h to the 6th. My base is h. 7 minus 6 is equal to 1. So I have h to the 1st. Now notice I don't ever leave an exponent of 1. It's implied. So your answer here would just be h. Do those on your own problems, and when you're ready to move on, we will start example 2. So example 2, you're going to take some things that you've learned from yesterday's 10.2 lesson, and we're going to combine those with today's. So we've got to do what we learned yesterday. 3 to the 4th times 3 squared. You add these exponents, and 4 plus 2 is 6. So this would be 3 to the 6th over 3 to the 3rd. And 3 to the 6th over 3 to the 3rd is what we're doing today. So now we're subtracting 6 minus 3, which is 3. So this is 3 to the 3rd. 3 to the 3rd is 27. Either of these answers, again, would be acceptable. Example 3 is a little different. A couple different ways you can do this problem. You can either work vertically, which I'm going to do first, or we can work horizontally, which I'll do at second. So if we're working vertically, this is our quotient property. So 10 to the 6th over, a to the 10th over a to the 6th is a to the 4th when we subtract, times a to the 7th divided by a to the 4th is a to the 3rd. And now we're adding a to the 4th and a to the 3rd is a to the 7th. Now I could totally do this the other direction. I could go this way if I use my pen. So a to the 10th times a to the 7th is a to the 17th. And a to the 6th times a to the 4th is a to the 10th. Now I have a quotient, and now I'm going to subtract, which is a, that looks like a 9, sorry, which is a to the 7th. Either way you do this problem, either vertically or horizontally, we get the same answer. Let's keep going. You have 3 on your own problems to do. Remember, you're going to do this part first on number 5. And you can either work up or down or side to side on problems 6 and 7. Either way works. Let's look at example 4, our real life application problem. So the projected population of Tennessee in year 2030 is about 5 times 5.9 to the 8th. Predict the average number of people per square mile in 2030. So we're going to use this model to solve the problem. We're going to have people per square mile is equal to the population in 2030 divided by the land area. I don't know my people per square mile. That's what I'm trying to solve for. So we're going to call that X. My population in 2030 is 5 times 5.9 to the 8th power divided by my land area, which I'm getting from right here, is 5.9 to the 6th power. Okay, so you got to look for a property that we recognize. I'm going to split this so it's easier to see. So I have 5 times 5.9 to the 8th divided by 5.9 to the 6th. Hopefully now you can see that this is going to be 5 times 8 minus 6 is 2. So 5.9 to the 2nd. And if you evaluate that, 5 times 5.9 squared, X is equal to 174.05. So there will be about 174 people per square mile in the state of Tennessee in year 2030. And I believe that is it. See you later.